Hey guys, so this video will be this video will be about the assembly instructions for your robots. Now there's a slight discrepancy between something that uses a brushless motor, like if you have a vertical or horizontal spinner, versus using the servo motor if you have a lifter. And I will get into those discrepancies later at the end of the video, but I will say that overall it's essentially the same process. So I'm going to go ahead, and since most of you guys have used the brushless motor, I'm going to go ahead and get into what goes into the assembly. I would say it's not that hard. It's more like it just takes a bit of time to put everything together. And as we go through the video and we do some soldering, just make sure that you are very careful and not to burn yourself or to get lead poisoning. Not very likely, but if you use leaded solder, make sure to wash your hands after every use, and be sure not to touch your hand, not touch your face. Other than that, let's go ahead and get into it. So here's Onyx. You guys have seen the instruction video on how to make this design, and if you've done this design exactly, this will be a walk in the park. I'm not going to say it's going to be harder for you guys who don't use the same exact design. Just be cognizant of the space that you have in your robots, but you guys should have already thought about that beforehand. So let's look inside. And you can see that to the untrained eye, this looks like a rat's nest. And in all honesty, this is probably the neatest set of circuits that I've seen during my time as doing electrical engineer. It's not as much as you think it is. You guys should have all these components. So here is the receiver. Receiver receives the signal from the transmitter, which is your remote controls that I'll get out to you guys soon. And it is able to tell the robot what directions to go and what commands to complete. Here are your two N20 drive motors. You can see they're pretty small. They have gear train in them, and they're affected by the gear train inside of them are affect the RPM, rotations per minute, and is able to determine how fast your robot goes. If you are one of the college freshmen, you'll probably get something that's a bit more high RPM, whatever we can find in the closet. But if you're one of the Haas Hall students, your RPM should be around 100 or 200, so it goes a little slower. It's just for controllability mitigation. And then here is your female JST connector. Now this is the part that connects to your battery. You should all have LiPo batteries. And so it's just a connection point in order to give your robot power during the competition. If you're using a brushless motor, you will need this ESC. And this ESC is only goes with the brushless and not the servo, as it is able to affect the PWM signal in order to effectively change the signal from what's coming into the receiver to the brushless motor, because it uses a different type of code, if that makes sense. So that's what this PCB is for. And it should look similar to this. And then here is your Just Cuz PCB switch. This is really simple as using an Allen wrench and turning it on and off, lefty loosey, righty tighty. Did that on purpose because it's much more easy for the platform of BattleBots. And that is about it. So we're going to get, oh, no, actually, there's one more. And this may be dependent on where you have your brushless motor, but it all should essentially be situated in a central area. Here's a brushless motor. We've talked about before how I suggest that you make your weapon in a way to just sit on top, because of this nice little screw that accompanies the brushless motors. It's easy to screw on top. And you can kind of see where the wires go in from underneath over here, and then going through this hole right here, connecting to the ESC. And so that is all of the components, including the, what are these called? Including the zip ties that I've given you to tie down your motors, as well as the wheels, but those are pretty simple. Also with the wheels, if you designed your wheels in a way to be inside of the robot, it's not really, a big deal. You should have already designed for that, account that eventuality. But just be cognizant of space as well, like I said before. So it's going to end up looking something like this by the end of this video. So we're going to go ahead and get started into it.